If you need to optimize the design of a cam, poppet valve, and valve spring for an engine design which utilizes overhead cams, SOLIDWORKS has many built-in tools to streamline that design task. As you can see here, in an assembly with a simple cam and poppet valve mated to these two perpendicular axes, you can begin the analysis. The first tool to use is the motion analysis tool, which you can enable here in the add-ins toolbar. Next, go down to Motion Study and change the animation drop-down selection to motion analysis. Then, go into settings on this gear right here and change your frames per second in motion analysis to at least 2000 frames per second. Slide the 3D contact resolution to about 2 clicks beneath the maximum and enable precise contact. Finally, change your cycle rate to at least 1000 per second. 2000 usually works better. Your accuracy should be fine where it is. Now, you need to add a motor to drive your cam. The motor can be accessed here. To start with, set the motor which drives your cam to spin at the lowest angular speed that you know your engine will need to idle at. Then, slide the upper key of your motion study down to about half a second, or maybe even less than that, to ensure that your cam won't just be a blur when you look at it as you run the animation. It's time to make the cam and the valve interact with one another. This is the most important part. Make a contact relationship with this button here and select both the cam and the valve. Set both materials to dry steel and make absolutely sure that you disable the friction feature. Finally, you'll need to input your spring. In order to do this, you'll need a stationary surface for the spring to be seated on opposite from the seat on the poppet valve. If you haven't designed this interface yet, a simple analog like this one here ought be satisfactory for initial design purposes. Once the seating piece is visible, select the spring feature here and click on both the concentric edges of the seat and the concentric edge of the valve stem respectively. The spring should default to a linear spring assumption and will default to a free length equal to the initial distance between these edges. Given that your valve springs should always be preloaded, extend that free length by a factor of about 1.4 or 1.5 to start off with. The spring should turn red if you've done this right, but it may not in previous versions of SOLIDWORKS. Now that everything is ready, set your playback dropdown to a fixed time of 10 seconds and calculate the study with this button and see how it looks. Depending upon the dimensions and weight of your valve, it will either exhibit no valve skip like this, or extremely severe valve skip, which you will probably see later in this video. Given that there doesn't appear to be valve skip in this design, I can now raise the rotation rate of the cam to the RPM that it would experience at redline. After witnessing a comically large amount of valve skip, I can safely conclude that one or many of three things needs to happen. The preload of the springs needs to be larger, meaning I extend the ratio of the free length of the spring to the compressed length of the spring. The K value of the spring needs to be increased, or the weight of the valve needs to be decreased. The sensitivity analysis of these three parameters, although highly critical to a preliminary design of any complete engine, will not be elaborated upon in this video. I recommend these texts for further reading, and we may explore this topic in a future video. After thorough tweaking of these three parameters, you get to a point where there is no longer any discernible valve skip. The next step at this point is generating a plot of height versus time of the valve in order to more thoroughly inspect this design. You can add a plot by clicking on this graph button right here, selecting displacement, linear displacement, and magnitude respectively, and then selecting two entities on the stationary object and the moving valve. The number of data points in this curve is driven by the frame rate of the motion analysis. Other plots ranging from acceleration to motor torque can also be measured this way. A full write-up of this content can be found on GitHub at github.com/minutetips and on our website at minutetips.net. Both of which you can find linked in the video description down below. Thanks for watching.